My name is Dimitri. As you heard, I will be giving this talk in English, as is obvious. I will be talking to you about how to use Chef to achieve this cloud provider independence. First, I'm going to give you a little introduction so we all understand where we are, what we understand to be a cloud. Then I'll go into more detail about what Chef is and how we use it. And at the end, I'll show you how we can achieve this independence using Chef. First, I'd like to ask you, what does cloud mean exactly? That is a hot topic. That's why we're all here today. For those of you who are here a bit early, I asked you to write down what your definitions were. And so I'd like to pick a couple of you to read out your definitions in just a minute. Then we're going to, after we do that, talk about how that impacts your applications, how we can have to restructure applications in order to fit onto the cloud, and then tell you a bit about the cloud we built at Everywhere and what we understand to be a cloud. So first of all, what is a cloud? Does anybody have something they'd like to read? What do you understand to be a cloud? Okay, good. Compute and storage resources over the network. What else? Yeah?
Probably there's three layers, there's three cloud layers. There's infrastructure as a service, platform as a service, and software as a service.
Right.
And the infrastructure as a service is a bit like a data center with an API.
Okay. Infrastructure as a service, platform as a service, software as a service, and infrastructure as a service, you said, is a bit like a data center as an API. Good. Okay. I'm sure if we were each able to tell what cloud would be, we'd hear a different opinion. Each have a different idea of what a cloud is. I'm here to tell you that regardless of if you're using IaaS, PaaS, or SaaS, you're going to use the same methods in order to build your infrastructures onto the cloud. So you can have an infrastructure as a service, a platform as a service, software as a service. They all have an API, all have an endpoint that you need to talk to. And your orchestration software is that which will be constructing your infrastructure. You're no longer going to be doing things by hand. You're not going to be editing configuration files. You will be using some other piece of software in order to construct and manage your infrastructure. And that brings us to scale. Scale is typically understood as being in two dimensions. You can scale up, which means you add more resources to an already existing node. If you need more RAM, you can add more RAM. Same thing with disk or CPU power. Or you can scale out, which means adding more nodes. And typically at cloud scale, what we talk about is scaling out. You want to add more nodes in order to do the same things that existing nodes already accomplish. And this is a bit of a paradigm shift for some people. Servers are not houseplants. You no longer install a server, construct your application, install that application onto the server, fine-tune it, manage it, make sure it runs perfectly, and then bring that server into production. That is the old way of thinking. Nowadays, we are heading towards an era in which servers are wheat. You plant seeds in a field, and you watch them grow. If you need more wheat, you just get another field. And if one field dies, that's not a problem. You can tear it down, you can just grow another one. It doesn't make a difference anymore. The individual server is no longer important. It's what they accomplish as a whole. And this has implications for your application. you're no longer going to be able to organically grow your application into a state in which you can bring it into production. You're not going to work on a VM on your laptop until it's in a state where you feel, yes, this is something I can bring into production, and then just carry that on into production as is. You're going to think about it in a different way. You're going to be able to, instead of replanting the server, taking it from one place as is and bringing it to another, you're going to be able to tear it down and build it up again. Because everything that you have, all the effort, all the development that you've put into making that application run is now contained in an orchestration framework. It's contained outside of your application, outside of the infrastructure, but we'll see over both. And this is what we looked at when we wanted to build the cloud. We looked at the different systems that were out there, OpenStack, CloudStack, very early stages. We decided to go with Joyent's Smart Data Center product. This is a product that basically enables you to rack a set of servers, plug them in, turn them on, and use them as that field upon which you can plant wheat. Those VMs that you'll spin up are provisioned over an API. And this is all based on the hypervisor Smart OS. It's a Solaris derivative, and there are 4 key technologies that we really thought were important, especially in the area of cloud, multi-tenancy. Zones are able to partition off your individual customers into separate containers. ZFS, we have KVM as well for those that want to run on Linux or Windows systems. Those are placed within zones themselves so that they are still partitioned off. ZFS is the answer to all file system questions we've ever had. If you want your data to be safe, it's written to ZFS. And Joyent has added something to ZFS that makes it a very good neighbor. So if you have one zone that is using a lot of I/O and another one that's not using very much but still needs to deliver, it's able to do that with something called I/O throttling. And then the last technology that they brought in was dtrace. This is an introspection tool that you can use to see the entire stack from the kernel through the I/O subsystems, network, disk, and into the application. So you can see what's going on in each layer. And in the end, when you put this together, you have a very robust and stable, fast cloud system. Are there any questions about any of that so far? Yes?
Why is your cloud solution better than the Cisco cloud solution?
I'm not saying it's better. It's different. Yeah?
Talks and cloud solution. This is the super car, this is the smaller car. What are the real benefits of your solution to other cloud solutions?
We can talk about that. I'll be happy to talk about that afterwards. That's not the focus of this talk right here, though.
What's the benefit? What's the benefit to the users?
High performance.
Measure. How do you measure your performance? Have you measures?
Yes. I'll be happy to talk about this afterwards. Any other questions? Yes.
And what's the size of your scale?
The size of the scale, it depends on what you'd like.
Do you operate one or you just use one?
But we operate one. We operate. At the moment, we have on the order of 30 nodes. Other questions?
Joyent is not open source. Is it?
Illumos is, Smart OS is open source. The underlying technology is open source. Yes.
What's the API you offer to consumers of the cloud? How do they consume cloud services?
They have an API as part of the Smart Data Center, and you're able to provision machines, resize machines. That whole thing is accessible to the customer. Yes?
If you would rebuild a cloud today, would you still choose the same components? As you would?
Yes, I would. Yes.
Well, only a question. Is this easy to integrate into this scalable libraries like Auto or cloud? Or is it already integrated?
It is integrated into Chef, which I'll be talking about a bit later. So, okay. Yes?
Does it only run on joins infrastructure, or can you run it on boxes in any data center anywhere?
You can run it on boxes in any data center anywhere, provided the drivers are there. We run it on HP hardware, but it doesn't have to. Okay. All right, let's dive into Chef. What is Chef? And talk a bit about the basic architecture and then how we actually use it. What Chef is a new way of looking at your infrastructure. Chef is a tool that ops code open sourced. They developed it for themselves and then felt that other people could use it. It is a way of writing your infrastructure the same way you would write your application. You think about your infrastructure as code. So you write your code right now to create an application and run it somewhere. And with Chef, you can write out your infrastructure as code and run it like you would an application. This is a basic architecture that Chef systems have. It focuses around the administrator's workstation. That could be your laptop, could be your PC at work. You write code. You check it into revision control, just like you would your application code. And then you upload it to the server. In this case, you use a tool called Knife. You upload it to the Chef server. That's where all your infrastructure code lives. That's where it runs. And then your nodes are configured to talk to the Chef server, pull information from the Chef server, and deploy it, configure your system to make it run the way that you want it. It's a very high-level view. We're going to go into more detail about each of these steps later on. And how we use Chef is as a configuration management tool. Chef is a framework. You can use it for many different things. We choose to use it for configuration management, so we can control the configuration on those nodes. Any questions about the quick flyby of Chef? Yes?
There are many other similar tools like CF Engine and tabelle.
Yes.
And what do you think is the best choice? You choose Chef, but how do you compare these three tools?
About 3.5 years ago, I evaluated the different systems, CF Engine, bconfig2, Puppet, Chef, and I found that Chef met our needs the best. It basically, you want to choose a tool that fits your way of working and your team's way of working the best. And so for us, a Chef, for somebody else, it would be Puppet or bconfig2. It doesn't matter. It's important that you use a tool like this to manage your infrastructure. Any other questions? All right, well, let's talk about how we can use Chef to achieve this independence. What we want to do is talk about the concepts, take Chef apart, look at it, what are the different pieces, and then use that to write some configuration, see what it looks like actually. And then once we have the configuration separated, we make sure we keep the application code and the application data separate as well, so we can then deploy them to the cloud to scale. Chef is a very broad topic. I'll just be covering 3 different areas: roles, recipes, and data backs. Roles encapsulate pieces of your infrastructure. You can think about your infrastructure the way it is right now, and you could divide it up by function. Say I have these web servers over here. All these nodes are web servers. These other nodes are load balancers, and they each have specific functions. They also have particular pieces of data. For instance, this listens on port 80. And I want to run Nginx on these nodes. If you think about your infrastructure in this way, you can take these pieces and then be able to mix and match them to create what you need by using these roles. This is an example role. This is exactly what it looks like. A role has a name. This one's called Nginx PHP MySQL. And because this is code, we want to document our code so other people can read it, and so it has a description. This installs and configures Nginx, PHP, and MySQL to work together, so I know exactly what this role is going to do. I have pieces of data that tell me how it's going to go about doing it. For instance, I want MySQL to listen only on localhost. I don't want it to have any other network connections. And so I say the bind address is going to be 127.0.0.1. This is something I put into the role. I also want to make sure that PHP FPM is installed because I'm going to be running PHP under FPM. And I know that I'm going to be talking to MySQL, so I make sure the MySQL module is installed as well. At the bottom we have this run list, which means basically what different things are going to run in order to get the node into this state. We're going to talk about that in just a bit. A run list can consist of recipes or roles. Roles can be nested. This one has recipes to do PHP, MySQL, managing users, etc. It also includes the role reverse proxy Nginx. Somebody tell me what they think this role might actually do. Reverse proxy Nginx. Anybody? Wild guess.
Configure Nginx as a reverse proxy.
Very good. Configure Nginx as a reverse proxy. See, we name our roles, we give them names to actually mean something. And so we know exactly by looking at it, okay, I'm going to have something configured. I'm going to configure Nginx as a reverse proxy. Recipes, that's what you saw at the bottom there, the run list. Recipes are the actual code that you use to configure that node. They're made up of a couple of different pieces. You have resources, files, users, packages. There are different things that you want to put under configuration management in order to install them, in order to configure them, make sure that they're running. You have attributes. These are those pieces of data that we saw before, like MySQL, listen, the bind address is 127.0.0.1. These are things that will combine together in order to bring that node into the state that you want it to be in. And recipes are collected in things called cookbooks. A cookbook covers basically one piece of software. There's an Apache cookbook in which all the recipes that are used to configure Apache are collected. There's a PostgreSQL cookbook in which you would collect all your recipes in order to configure PostgreSQL. This is an example recipe. I'm not going to go in too much detail here. It's written in Ruby, which makes writing a DSL, a domain-specific language, fairly easy. You have up here packages that you want to install. They're given by this attribute. You read this out at compile time. A directory, which has a certain owner, a group, a mode, and you want it to create all the parent directories. And at the bottom we have a template. It's another resource. We are able to put a script on there and have variables in that script that get replaced depending on the different attributes that are set for that node. The last chef concept that we're going to be going over is data bags. Data bag is basically data. That's all it is. It's just a bunch of data about your infrastructure. You can have virtual hosts in data bags. You can have users. You can have databases, so that you know, or you can control which virtual hosts are active on which nodes, which users should be provisioned on which nodes, etc. And this is what a data bag looks like. It's in JSON format, JavaScript object notation, which basically means that anything between two curly braces is an object. You can nest them. You have a colon to separate the key from the value. Anything in quotes is a string. You can have arrays. You can have hashes as well. So whatever fits your way of thinking about this data, you can construct it in JSON format and use that in your recipes. Recipe takes the data from the data bag and creates something on that server. And now that we've written these roles and recipes and put our data in the data bag, how does that actually get onto the server? We use these tools that we went over in the overview to apply the configuration. Knife is the first one. It's the command line tool. Knife talks to the Chef server. It uploads your code that you've written to describe your infrastructure to the server. Knife can also query the status from the server, so you know the status of all your nodes. You can find out if a node hasn't checked in, and then find out why. If Knife doesn't already do something that you would like it to do, it's modular, you can write a plugin. If, for example, Knife did not already communicate with your API, you can write a plugin that would handle that communication. There are already plugins for EC2, for Rackspace, for Joyent. All the major cloud providers are already integrated within Knife. And so you can use Knife to bootstrap your infrastructure. You've written your nodes, you've written your configuration, your roles, you got your data in your data bags, you have your recipes, you have them all uploaded to the Chef server, and now you can talk to your provider through the API and bootstrap your infrastructure. How that happens, the Chef client is a daemon process that runs on the node itself. You can run it as a daemon or as a cron job even that will periodically query the Chef server. It will tell the Chef server, I am this node, tell me my configuration. And then the Chef server will say, okay, you have this and that role, you have this run list, go and do it. And then the Chef client takes that information, expands it out, takes all the variables that you have, all the attributes that you've set, substitutes them in, and writes out the configuration. Now, writes this into a temporary location, compares it to what is already on the server. Say you've already installed Apache. You don't have to install it again. You've already configured Apache. It doesn't need to be configured again if it corresponds to the configuration that you have in the Chef server. If that information is already stored in configuration management, it will ensure that that information stays the same. Your configuration will not change by somebody going to the node and making an edit by hand. The next run of the Chef client will overwrite that change. Oops. There we go. And so that's how you can bring these nodes into a known state, because everything is controlled by configuration management. You have your attributes, you have your run list, and the Chef client will expand them out and write your configuration the way you need it to be. The second piece of this independence is making sure that you have your application code in a way that you can deploy it to multiple nodes. You already have it checked into a repository, I'm sure, or have it deployed to an artifact server so that you can call it from anywhere or anywhere that you need to. You have a deployment framework, for example, Rundeck, that will that will be able to take that code out of the artifact server and put it onto your nodes. And then you need a source of truth. In this case, it's Chef. We use Chef as the source of truth for the infrastructure. You know all the nodes, you know the roles, you know exactly what should be on each, And so you tell Rundeck to deploy this package onto the nodes that have this role. And then the data, the application data, depends on your application, of course. If your data is stored as files, you put it into an object store. If you have relational data, you store it in RDBMS. And if you have key value data, you store that in a key value store. Most cloud providers will provide all or some of these types of storage. So in order to be able to move your application from one provider to the other, you describe the infrastructure in Chef, and you keep your data and your code separate, and you're able to tell through your deployment framework where everything should go. Some lessons learned in implementing all of this at work. Takes a bit longer to add OS agnosticism to these cookbooks. Chef is a very vibrant community. Each person has their own way of doing things, and if you find that somebody else's way of doing things doesn't exactly work on your server, then you have to do it a different way, and that takes a while. One of the benefits, though, is that these nodes are bootstrapped very quickly. You can get one up in 2 or 3 minutes. If you'd like to learn more about Chef, there's a URL that they've activated, learnchef.com. There's different ways of doing things than how I described. You can, for example, instead of using a deployment framework, you can write an application cookbook. The application cookbook will actually do those steps for you. Deploy your application how you want it to be, just like you would your infrastructure. And Vagrant is a tool that you can use to set up a virtual infrastructure on your laptop, write all your infrastructure code there, test it out, and then bring that to a cloud provider to do your production, to do your QA environment. And so in order to have this migratable infrastructure, you have to keep those 3 pieces separate. You have to keep your configuration separate from your application code, separate from your application data, and be able to talk to each of those through in a configuration management framework. Are there any questions? Yes?
Do you use Chef also to, if you have a parameter model you want to be part of your joint cloud, do you also use Chef to deploy the software needed to be part of the cloud, or only for the VMs that run on top?
Both. You can, besides the cloud infrastructure, we have bare metal infrastructure that is for a different kind of customer, and we use Chef to manage those servers as well. Yes?
Well, if I have already deployed an application and you want to make changes to the configuration, how does it help to make sure that they don't make mistakes? Things don't match really.
You need a question was, how do I make sure that once I have everything in configuration management that I don't make a mistake if I want to make a change? There are different workflows that you can use. You can have one workflow in which everything that gets deployed to the production infrastructure is checked into a production branch in your revision control. And then make sure that you have a QA branch or a staging branch or a testing branch. And make sure that you're, just like you would with an application, that you check in those changes to the appropriate branch. And you could use a CI framework like Jenkins to automatically deploy those changes onto your infrastructure.